I'm Zane from thecarbondoctor.com, and today for our whiteboard lecture, we're going to continue our discussion of stoichiometry. And last time we used this particular reaction between solid P4 and potassium to yield K3P7 as our example, so we're going to continue with that. We reacted 17 grams of P4 with 15 grams of potassium, and we found that there was a limiting reactant, which was white phosphorus. And if you're wondering where this reaction came from, again, you can check out our other video. It'll be linked in the description of this video. So if you want to go back and review how we got to these values for the theoretical yield, or figured out the limiting reactant, the one that was all the way used up in this particular reaction, causing productive reaction progress to stop, check that out. So again, some other things that we can do with stoichiometry, other than just calculating a theoretical yield, would be to determine how much of an excess reagent that we had, assuming we had a limiting reactant, which we did in that previous example, right? So our P4 was limiting. That means our potassium is actually added in a little bit excess. So often we're wondering how much in excess. Or something else we could do is figure out from a certain amount of any individual reactant what would be the stoichiometric amounts of the other reactants we wanted to add so that there wouldn't be any excess. So we're going to sort of examine this a little bit in this particular video. So again, we combined these two amounts of reagents, found P4 was limiting, so we want to know how much potassium is in excess. There's actually a couple ways we could go about it now that we have the theoretical yield of K3P7 calculated. So I'm going to show you simultaneously sort of each of these methods. So one method would be to take the limiting reactant amount and to convert that not to the product but to the other reagent, right? So we take grams of P4, go to moles of P4, so we're doing stoichiometry. Then we use the mole ratio of P4 to potassium to figure out how much potassium we need to actually add in to leave no more leftovers, okay? So I'm going to write P4 here. 17 grams of P4, and we're going to go all the way to grams of potassium. That would be sort of method one. Again, the other method, because we have this balanced reaction, would be to take grams of the product and convert to grams of potassium. So that's another way you can do sort of the same thing. So I'm going to do that one sort of at the same time that I'm working through the P4. So you get sort of two different approaches to the same problem. So we'll write that up here. 26.2 grams, K3P7. And again, we're going to need to get into the realm of moles to do stoichiometry, so I'm going to convert each of these to moles of that substance. Okay, so there's going to be some number of grams of P4, some number of grams K3P7 for every 1 mole of that stuff, of that substance. And so if I get those numbers really quick, well, 123.9 grams of P4, and then for K3P7, 334.1 grams of K3P7 per 1 mole. So now we have the molar masses in place. That gets us to moles of P4 and moles of K3P7. Now, again, all we got to do is take our mole ratios to bridge between either limiting reactant to potassium or K3P7 to potassium. So we'll set up another bracket, kind of like we do when we do dimensional analysis. And so I know now that I just need the mole ratios, which are going to be those coefficients in the balanced equation. So for P4, there's 7 mole of P4 that are going to be used up, along with 12 moles of potassium to be stoichiometric, and there's going to be 4 moles of K3P7 used up exactly with 12 moles of K, right? So that, if we just think about canceling units, okay, that gets us to moles of potassium, right? So there we go. Moles of potassium, but we don't want to stop there, because the idea is to figure out how many grams of excess we added in this reaction, okay? So let's figure out the stoichiometric amount that'll be exactly used up along with the limiting reactant, and then I'll show you how we can calculate that excess, which is just one easy step, all right? So All we need now to finish it up, get back out of the realm of moles, is the molar mass of potassium in each of these cases. So for every 1 mole of K, that's going to be some number of grams of potassium. It's going to be 39.098 grams of potassium. Right? Okay? So now all we have to do is crunch the numbers in our calculator. Okay? And so if I take 17 divided by the molar mass of P4, which is 123.9, multiply by 12 sevenths, multiply by 39.098, what I get, and it should match if we've done this correctly, right? We're just going about it from 2 different approaches. To get that stoichiometric amount of potassium, these two should match no matter which direction we took. And when you crunch these, I get 9.20 grams of potassium in each case. So it does match. So I think we're in good shape in terms of setting things up correctly. So now, what is this value? So this is the stoichiometric amount of potassium that will get used up and leave no leftovers if we were to run this reaction, right? So if we wanted to have no leftovers, I will mix 17 with 9.20 grams of potassium. In a perfect world, it would leave no leftovers. In real reactions, that's hardly ever the case. But that would be the stoichiometric equivalent of our limiting reactant. So now, to find the excess, it's just one easy step, okay? What I'm going to do is take the 15 grams of K added to the reaction, and I'm going to subtract from it the 9.2 grams of potassium, which was used up, actually used in the reaction. And I'm going to get that difference, and that's all I have to do to get our excess potassium. So when we do that, what I find is that I get 5.8 grams of excess potassium. That will be how much we over added in terms of running this reaction stoichiometrically. We added that much in excess in our original example. So again, that's just some other ways that you can do stoichiometry, use stoichiometry. And I hope you enjoyed the video. We'll be back with more content soon. Thank you.